3 log x base 10 can be written as log to the base of 10. Our 3 will transfer to the x, become a power. So we have x raised to power 3. So we'll bring down our plus. Then log 3 base 10, we'll bring it down. And that's equal to log 81 base 10. Alright, so the next thing we're going to do, we'll be applying one of the laws of logarithm, which says addition changes to multiplication. So since they have the same base, we can pick one of them. I will say log x raised to the power 3 times 3. Alright, the base of 10. And that's equal to log 81 base 10. So the next thing we are going to do, x raised to the power 3 times 3 will give us 3x raised to the power 3. So we'll bring down our log 3x raised to the power 3 to the base of 10, and that's equal to log 81 base 10. Log 81 to the base of 10. So now that we have log base 10 and log base 10, they can cancel out. So we'll now deal with 3x raised to the power 3, and that's equal to 81. So we'll divide both sides by the coefficient of x raised to the power 3, which is 3. We divide by 3. So 3 cancels 3, we're left with x raised to the power 3. And that's equal to 81 divided by 3, we have 27. Alright? So we'll ask ourselves, what is the cube root of 27? That is, we are taking the cube root of both sides. So this cancels this, and the cube root of 27 is 3. So our answer is 3, and that becomes 3 times 3 times 3 will give us 27. So let's see the next question. So from the second question, we have 3 log x. There's no base here, no base indicated, and no base indicated. So whenever there's no base indicated, automatically that log has a base of 10. So we can now say 3 log x is the same as saying log x raised to the power 3. So this 3 will be transferred here, becomes its power. And that's plus log x raised to the power 5. That means we transfer the 5 here, it becomes its power minus log x raised to the power 6. The same thing we do here, and that's equal to 64. So the next thing we are going to do, we are applying the laws of logarithm, which says addition changes to multiplication and subtraction changes to division. So in doing that, we have log x raised to the power 3 times x raised to the power 5 divided by x raised to the power 6. And why are we doing this? Because they all have the same base, and their base is an invisible base 10. So we can now say that is equal to 64. Alright? So log x raised to the power 3 times x raised to the power 5 will give us x raised to the power 8. So we have x raised to the power 8 divided by x raised to the power 6. And that's equal to 64. Alright, so in doing this, x raised to the power 8 divided by x raised to the power 6 can be reduced. Alright, and that's because x times x means x raised to the power 2. So if we multiply x times itself 8 times, will give us x raised to the power 8. And if we do that for x raised to the power 6, we have x times x times x in 6 places. So when we cancel out, we'll be left with x raised to the power 2. Or simply put, in indices, we have been made to understand that division changes to subtraction. So if we have x raised to the power 8 divided by x raised to the power 6, is the same thing as saying x raised to the power 8 minus 6. And this is x raised to the power 2. Thank you. So I can write this as log x raised to the power 2 by cancelling out the x's. So I can have log x raised to the power 2. Alright? And that's equal to 64. Good. So now we can have log x raised to the power 2 is equal to, now we ask ourselves, what number multiplies itself a couple of times to give us 64? 4 times 4 is 16, times 4 is 64. So we can have log, alright, 4 raised to the power of 3. Are we together? So this can cancel this. So I left with x raised to the power 2, and that's equal to 64, which is the same thing as 4 raised to the power 3. So the square roots can be taken for both sides, and we'll be left with x is equal to square root of 64, and the square root of 64 is 8. So therefore, our answer is 8. If you find this helpful, don't forget to like this video and please share. Subscribe to my YouTube channel at Joe King Math Class, and follow me also on Facebook at Joe King, and on Instagram at official_Joe King. Thank you so much for watching. I'll see you in the next video.